a fruit salad with crunchy apples. But there is a catch. Leave it out in the open for a little while and the apples turn brown. Do you know why? It is because of a redox reaction. Let's meet in the studio to find out more about redox reactions.
Hello everybody, I am Devabrata Goswami. Welcome to Chemistry. Let's begin today's session by exploring redox reactions in detail and talk about the transfer of electrons in these reactions. In today's episode, we will discuss the meaning of oxidation number. We will then discuss the rules of calculating the oxidation number and then calculate oxidation number of elements in compounds and ions. Last but not the least, we will do a warm-up for the exams in Exam Decoded. Let's begin today's session with a quick rewind. You are aware that redox reactions are reactions in which oxidation and reduction takes place simultaneously. Recall that oxidation is the process of loss of electrons by any species and reduction is the process of gain of electrons by any species. Let us take an example of the reaction when a zinc rod is placed in copper sulfate solution. When we put the zinc rod in copper sulfate solution and watch for a while, we see that the blue color of copper sulfate fades slowly. The zinc rod starts dissolving in the solution and a reddish brown precipitate settles at bottom. This is copper. Now, what has happened in this reaction? A redox reaction has taken place between zinc atoms and copper ions. Zinc atoms lose 2 electrons and get oxidized to zinc ions. Copper ions gain these 2 electrons and get reduced to copper atoms. In this reaction, the loss and gain of electrons can be easily explained. But if we consider a reaction between hydrogen and chlorine gas, the transfer of electrons cannot be explained. So, a more convenient and practical method of oxidation numbers is used. In this method, it is always assumed that there is a complete transfer of electrons from a less electronegative atom to a more electronegative atom. You should always keep one thing in mind while analyzing redox reactions. Oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules. These rules are formulated on the basis that electrons present in a covalent bond belong entirely to the more electronegative element. Another term that is often used interchangeably with the oxidation number is oxidation state. Now, this sounds complicated, so let's make it easy by learning how to calculate the oxidation number of an element. This is done according to a set of rules. Let us discuss these rules first, and then we will discuss some examples. The first rule is that in the free or elementary state, the oxidation number of an atom is always 0. This is irrespective of its allotropic form. For example, helium will have an oxidation number 0. The oxidation number of each atom in chlorine, oxygen, and nitrogen molecules is also 0. The next rule is for hydrogen. The oxidation number of hydrogen is always +1. However, in hydrides like sodium hydride, the oxidation number of hydrogen is -1. After hydrogen, it's oxygen in the queue. The oxidation number of oxygen is -2. However, there are a few exceptions in case of oxygen. In peroxides, the oxidation number of oxygen is -1. On the other hand, in superoxides, the oxidation number of oxygen is -0.5. However, in compounds of oxygen with fluorine, like oxygen difluoride, OF2, the oxidation number of oxygen is +2, and in dioxygen difluoride, that is O2F2, the oxidation number of oxygen is +1. If the oxidation numbers of oxygen sounds complicated, fluorine is really simple. The oxidation number of fluorine is always -1. Can you guess the reason why? Keep thinking. I will take a short break and be back with the answers to this question and more on oxidation numbers. Welcome back. I am Devabrata Goswami and you are watching Chemistry 11. Before the break, I had asked you why the oxidation number of fluorine is always -1. Well, it is time for the answer. This is because fluorine is the most electronegative atom, so it will always tend to withdraw the electrons towards itself. Let's continue with the rules relating to oxidation number. Here is another one. For ions composed of only one atom, the oxidation number is equal to the charge on the ion. Sounds complicated? Let's make it easier by taking an example. The oxidation number of sodium in sodium ion is +1 and the oxidation number of oxygen in oxide ion is -2. The last rule states that the algebraic sum of the oxidation number of all the atoms in a compound must be 0. Also, in a polyatomic ion, the algebraic sum of the oxidation numbers of all the atoms of the ion must be equal to the charge on the ion. After a long list of rules, let us practice these rules by calculating the oxidation number of carbon in carbon dioxide. We know that the oxidation number of oxygen is -2. Let us assume the oxidation number of carbon to be X. Now, the algebraic sum of the oxidation number of all the atoms in a compound must be 0. So, the expression will be X plus 2 multiplied by -2 is equal to 0. On solving, we get the oxidation number of carbon in carbon dioxide to be +4. Now, what happens when the ion is polyatomic? How does its oxidation number get affected? Let's take the example of nitrogen in the ammonium ion NH4+. What would be its oxidation number? According to the rule, the oxidation number of hydrogen is +1. Let oxidation number of nitrogen be X. Sum of oxidation number of nitrogen and 4 hydrogens is equal to X plus 4. This will be equal to +1, which is the charge on the ion. On solving the equation, we have X is equal to -3. Hence, the oxidation number of nitrogen in ammonium ion is -3. After studying all these rules about oxidation number, let me test if you have got all this. And my question for you is there any other method to denote the oxidation number of a metal in a compound? Well, do you know the answer? Not a problem. I will tell you. Yes, you have one more method to denote the oxidation number of a metal in a compound, and the method is known as stock notation. In this notation, the oxidation number is represented in Roman numerals and is written in brackets after the symbol of the metal in the molecular formula. Let's see how you can do this by taking the example of ferrous chloride and ferric chloride. Ferrous chloride is written as Fe followed by 2 in Roman numerals within brackets Cl2, and ferric chloride is written as Fe followed by 3 in Roman numerals within brackets Cl3. Enough of my questions. Let's see what our young caller wants to ask us.
Hello sir, this is Rakhi. My question is, can we define oxidation and reduction in terms of oxidation number?
Well, this is a nice question, and the answer is yes, we can do so. Oxidation is defined as an increase in oxidation number of an element in the given substance. Reduction, on the other hand, is defined as decrease in oxidation number of an element in the given substance. Let us understand this with the help of an example. During burning of wood, carbon combines with oxygen to produce carbon dioxide. In this reaction, the oxidation number of carbon increases from 0 to +4. Therefore, it is an oxidation reaction. Also, the oxidation number of oxygen decreases from 0 to -2. So, it is a reduction reaction. I hope all your doubts have been cleared, but it's time to take a break now. When we come back, we will do a quick recap of whatever we have covered in today's class, and then you will get all the tips to ace your exams in Exam Decoded. But I will leave you with something to think about. Can you name an antidote for poisons that uses redox reactions? So start thinking while I take a short break. Welcome back. I hope you all are refreshed now and ready to listen to the answer of the question I had asked you before the break. Can you name an antidote for poisons that uses redox reactions? Well, the answer is potassium permanganate is a compound which is used as an antidote for some poisons. It acts as an oxidizing agent and oxidizes the poison. In turn, it itself gets reduced to solid MnO2. Now let's have a quick recap of whatever we covered today. In today's episode, we learned that oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules. These rules are formulated on the basis that electrons in a covalent bond belong entirely to the more electronegative element. We also studied oxidation and reduction in terms of oxidation number. Oxidation is defined as an increase in oxidation number of an element in the given substance. Reduction is defined as decrease in oxidation number of an element in the given substance. Now that we are fortified with the facts, let's move on to Exam Decoded. Welcome to Exam Decoded, where I will give you the ideal configuration to crack your exams. You know, Answering exam questions can also be an invigorating challenge, a lot like our rapid fire round. Let's go over the rules. This round has 5 questions for 1 mark each. You will not get more than 5 seconds for each answer. Track your scores carefully and I will tell you what they mean. Let's start with this question. During reduction, there is a decrease in the oxidation number of the element in the given substance. True or false? The answer is true. Second question. The oxidation number of lithium in LiH is A +1, B +2, C -1, D -2. The answer is A +1. This is because the oxidation number of hydrogen in hydrides is always -1, which makes the oxidation number of lithium to be +1 in LiH. Question 3. The oxidation number of which of the following is always -1? A. Fluorine, B. Hydrogen, C. Oxygen, D. Sodium. The answer is A. Fluorine. Next question. The oxidation number of a metal in a compound is also denoted by stock notation. True or false? This one is easy. It is true. Now for the last question. Oxidation number of carbon is 0 in A. CH4, B. CCl4, C. CH3Cl, D. CH2Cl2. The answer is D. The oxidation number of carbon is 0 in CH2Cl2. Time now to see how you have fared. If you have got all 5 answers right, then you are a high flyer and this is definitely your strong subject. If you have scored 4 or 3 on 5, then you are an achiever. You are doing well, but a little more practice is needed. If you have scored less than 3, then you are a learner who must keep studying hard to master this topic. But no matter how you did in your rapid fire round, do log on to www.topperlearning.com for many more tests and question papers. This topic, oxidation number, is a part of the unit redox reactions. It has a weightage of 3 marks, so it is important. Probable questions from this topic will be of numerical and conceptual ability on how to calculate the oxidation number of an element. Usually, short answer type questions of 2 or 3 marks are asked. We will discuss one such example for finding all the terms discussed in today's episode. Let's take the reaction on your screen. 8 hydrogen ions react with 1 dichromate ion and 3 sulfite ions to give 2 chromium ions, 3 sulfate ions and 4 molecules of water. Identify what is oxidized and what is reduced in the reaction. This question is of average difficulty and will get you 2 marks. Let's see how we are going to write this answer. Writing the correct oxidation number for all the elements in this reaction will fetch you 1 mark. Since the oxidation number of chromium is decreasing from +6 to +3, in this reaction, chromium is reduced. This will fetch you half a mark. Since the oxidation number of sulfur is increasing from +4 to +6, it is oxidized. And this statement will give you the remaining half mark. Let's listen to some handy tips given by our expert on this subject.
Oxidation number is the formal charge on any element in the molecule. For example, KMnO4 is the molecule, but if we want to define the oxidation number for Mn, it is +7. So for determining the oxidation number of any element in the compound, we must know the oxidation number or oxidation state of other elements which are surrounding by the center atom. For example, in K2Cr2O7, chromium is surrounded by K and oxygen. K is being alkali metal is having +1 oxidation state, and oxygen in general having -2 oxidation state. By summarizing, the oxidation number of chromium is to be calculated, and it is +6. The electropositive element, for example alkali metals and alkaline earth metals, they are most electropositive element and will bear always +1 and +2 oxidation states respectively, while fluorine, being most electronegative element, will bear -1 oxidation state always. Oxygen, if combined with fluorine, can bear positive oxidation state, but fluorine always bear -1 oxidation state. Likewise, hydrogen can have both all the three oxidation states, that is +1, -1 and 0. When it is in native state like H2, it is bearing 0 oxidation state. Hydrogen, when combined with electronegative element, will be a positive oxidation state, and hydrogen, if combined with alkali metal and alkaline earth metals, which are called hydrides like lithium hydride, sodium hydride, calcium hydride, the oxidation state of hydrogen is -1. So oxidation state can be determined mutually. The oxidation states of each and every element we must keep in mind overall, and that's how the unknown element's oxidation state can be determined.
It's time to say goodbye now, but I will meet you again in the next episode with one more topic and some more questions and their answers. But I will leave you with some food for thought. We saw how apples turned brown when we cut them and left them in the open. But when we squeeze lemon juice on a slice of apple, it does not turn brown. Can you tell me why? To check if you have got the right answer, log on to www.topperlearning.com and keep thinking. This is Devabrata wishing you all success.